Welcome everybody to this edition of Exail. The format for this episode will be a little bit different. I'm joined in the studio here by Guillaume Udelaine, who's our DriX expert. We're going to be talking about DriX, and the format will be along the same lines as our other webinars. The idea is to give you a brief sort of introductory presentation, maybe 10-15 minutes or so, which Guillaume will help with, and after that we will embark on some question and answers. So please don't hesitate to post any questions you have, general questions or questions raised from the presentation. Our goal is to answer, if we can, all the questions. So depending on how complex they are, that may or may not take a certain amount of time. So let's see. We don't know how that's going to play out, so we'll just see how it works out. So here at XBlue, one of the key strategic directions that we're pursuing is around autonomous systems, and including maritime autonomous systems. And we've really got a number of core competencies in that area that we've evolved and established over many years. The first of which is probably inertial navigation systems that we've been evolving and developing for the best part of 20 years, which are widely used in underwater autonomous systems, as well as various other airborne systems, satellite remote sensing, and so on. So we've got plenty of competence in that area. We've also got our shipyard in the south of France, which has obviously developed DriX, but has been involved in developing other surface platforms with unmanned or remote control capacities. And then in recent years, we've been developing the autonomy and the guidance systems, autopilots, and so on that come into DriX. So this all comes together in the DriX platform that we're here to discuss. And so what I'm going to ask Guillaume to do is to give us an overview of DriX initially, and then what we'll try and do then is to look at a few case studies of some of the work that we've done in the past year or so. Just to inform the viewers and hopefully raise some questions. So Guillaume, we're here to talk about DriX specifically. Maybe you can just give us, the key points, the key takeaways. What's so great about DriX?
Well, first of all, David, thank you very much for having me here. So in a nutshell, what DriX is, it's an 8 meters long USV dedicated to conduct underwater survey, mainly. Okay, so as you can see on the model over here, DriX is fitted with a drop kill, and the sensors, antennas, are housed inside what we call the gondola at the bottom of the drop kill. The gondola varies in size and shapes, depending on the sensors one wants to put inside. So now the sensors cabinet, the electronic part, if you will, is located on the forepart of DriX, on the main hull. And this is called the electronic cabinet. So I just wanted to precise that before starting, in view of the coming questions. Now, the three key differentiators regarding DriX, in my views, are first of all its stability, then its speed, and the third one would be the launch and recovery system.
Okay, so top of the list then, stability. Why is that so important, Guillaume?
Well, the stability is important because the philosophy behind DriX is to provide the best possible data gathering environment. So with the stability, we don't suppress the movements of any ship sailing at sea, as you can see on the video, but we keep it within the sensor's tolerance, if you will. So that's why stability is of essence for the first part. The second one is for the comms. Okay, communications. As you can see on the top part of DriX, you've got a number of communication antennas, and if you don't have a good stability, then the antennas are going to move from port to starboard, and you run chances of losing your signal. Now, what are the results of stability in itself? Let me illustrate that with a quick example. A couple of years ago, we've done job in the Tonga Island. It was all about seabed mapping. Maybe I think we've got an image of that. Yeah, here it is. So we had one regular surface asset, and we had the DriX. The regular vessel was 30 plus meters long and was fitted like the DriX with the same sort of MBES. That was an EM 2040 Charlie dual head from Kongsberg. So the settings were the same. Both assets, the DriX and the surface assets.
Okay, so here we've got the survey coverage from the DriX on the top here. So 100% coverage, and from the surface vessel or the mothership, we've got obviously a less perfect data set.
Absolutely. Yeah, you're absolutely right about that. And this was taken at the same moment, in the same location, same sea conditions, same settings. And that's what matters. So basically, on DriX, the EM 2040 Charlie was going deeper and showed more density than the one mounted on the surface asset.
Okay, so stability is top of the list, and that's all about deploying sensors in the best possible environment and conducting surveys at the most advantageous speed without degrading that sensor data. So second on your list was speed. Why is speed so valuable?
Well, here again, two things. First of all, thanks to DriX hydrodynamics, we can conduct survey faster, as long as the data density is guaranteed by the sensors. That's the first thing. The second thing is DriX is all about gaining efficiency. So with a top speed of 14 knots, 1.4, then you tremendously reduce the transit time to the area of operation, if you will. And that's what speed is all about. Here again, I've got an example. Last year, we were operating for an oil and gas contractor in the Gulf of Mexico. A lengthy survey, several months. Anyway, DriX was operating from the shore, casting off every morning and going to the area of operation. Then, all of a sudden, the contractor was asked by the end customer to perform another survey 90 kilometers away from the usual area of operation. And the contractor didn't have any vessel which could act like a DriX bearer, like a DriX mothership. So we had no choice but to use a small PLV and have DriX run behind it. And that's the beauty about the speed here. DriX can cope with a transiting surface assets and still work. As you can see here, DriX is using what we call the follow me mode, which is a way to tell the autopilots, well, okay, you stay at a given distance from the vessel, okay, a distance never to exceed, and you mimic the vessel movements. So in that case, DriX sailed 90 kilometers to the area of operation, performed the survey, and was back in the evening, 90 kilometers again, to the harbor. So that's a good use of speed.
Okay, so it's giving you operational flexibility,
yeah,
and to get to a work area from a harbor or maybe remote from a mothership or other operations. Conduct the survey, come back in time for
absolutely.
and presumably the power and so on and the speed is valuable in strong currents or strong tidal streams. I imagine also
yes,
gives you some advantage.
It gives you a provision of sea handling if you prefer.
So stability, speed, and the third one you mentioned was launch and recovery.
Yeah.
So tell us, why is that so valuable in your mind?
As far as I'm concerned, when one is talking about an autonomous system, the launch and recovery system accounts for 50 to 60% of the operational value. Clearly,
right.
It's all a matter of being capable of launching and recovering your assets. And that's as clear as that. So we've designed what we call the DriX deployment system. Oh, here it is. In essence, that's a 1 or 2 lifting point device with a rib hole shape, I would say, which can be used from a davit, from a crane, or from an A-frame, from any lifting device, really, as long as it has the necessary power to lift 3.2 tons, which is the global weight of the DDS and of the DriX. Okay, so don't get me wrong, DriX can be lifted without the DDS from a pier, for instance, from a quay. But I strongly recommend the use of the DDS, which is going to give you a lot more flexibility in the way you employ it, because you can use it up to sea stage 3, which is not bad. It gives you stability, and it also acts as a shelter to protect your DriX during the lifting, the launch and recovery phases. The interesting thing about the DDS is that it's an intelligent piece of kit. It's fitted with positioning devices, which are going to dialogue with DriX autopilot and allow for automatic recovery, so no hands-on. Okay? So the way you use it, you keep a forward-going speed to keep stability. So I would say between 3 to 4 knots. Okay, just like for rib operations, in a sense. That's what it's all about. And then DriX is going to approach autonomously the DDS and conduct the final approach through its LiDAR, and in order to get inside the DDS. So that's it. And once you lift DriX, the drop kill here retracts, and you can put it on the deck, on a davit, or whatever. I would like to mention just one more thing, and that's that the DDS is always attached to the lifting device. Okay, it's not going places
it's not
to recover. No.
Maneuvering.
Absolutely.
Okay. Yeah, very good. Okay, so in summary, then your three takeaways: stability, speed, and launch and recovery. Strong launch and recovery credentials. Multiple options in terms of davits, A-frames, cranes, from the quay, from vessels, and so on and so forth. Okay, so now let's have a little dig into some operations. What's DriX been up to in the last 12 months or so?
Well, I'll try to keep it compact, because I know we don't have a lot of time. Anyway, we've been working cross markets extensively. So the first topic I'm not going to address is the naval domain. Okay, so we've worked in that area, but that's not my point today. We've also worked for the oil and gas industry, as well as for the renewables and for the hydrographic industry, of course. So if I could give you a couple of examples, for instance, I mentioned renewables. Okay, let's start with that. For the renewables, we've been operating on wind farms, mostly in the UK, in the North Wales vicinity. So every time, the interesting part about that one was that we are granted the access to the wind farm with DriX, because the HSE hazards were judged fairly limited to the gas turbine, clearly, the kinematic energy mainly. And that was quite interesting, because, and I think we might have a movie on the wind farms. Yeah, here we are. So that's the energy operated wind farm. So we are doing seabed mapping and looking at cables underneath. Every time DriX was fitted with a T50 from Reason multi-beam echo sounder, dual head with a very specific shape gondola to accommodate it. And it turned out that we had an excellent line keeping over the weeks. We've worked over there, because the cross current was no less than 3 knots in general. and the maximum drift from the scheduled course of a ground was less than 1 meter. So that's quite breathtaking in my view. So that's the first thing. The second thing is that thanks to DriX maneuverability, we were capable of working 3 times faster than an accompanying surface asset here. So as you can see, this is a view from QPS, from Quincy, from QPS, which is exactly what the surveyors see on the spot from the remote hydrographic computer. So that was all in all, those were interesting missions we had there. Now I talk about renewals. Yeah, another example which is hydrography focused, but it's even wider than that. So we've done some extensive trials with NOAA. You know, the US Hydrographic Administration.
Okay, and we saw the David launch arrangement.
Yeah, absolutely. Okay. That's so the launch with the David was one of the test points, but not only. The more general picture was to make, and that's very interesting, was to make DriX an organic part of the vessel. So basically, what NOAA did was take away one of their launch and a survey launch and replace it with the DriX. And it was all a matter of having a crew being accustomed to routinely operate the DriX. And this is easier said than done. And it turned out that it was quite easy. Well, the crew was highly motivated and was very supportive. We had a great time with NOAA, clearly. But also, it turned out that making DriX a part of the system was fairly easy. So that's that accounts a lot for the future operational value in that frame, if you will.
Okay, very interesting. So that's the sort of the renewable area, shallow water hydrographic or geophysical survey. The more hydrographic type orientation with NOAA, and then clearly there's been quite a bit of activity in the oil and gas sector with the Gulf of Mexico job you mentioned earlier and some other activities.
Yeah, absolutely. Yeah, we've been working with Total performing vaccines. We've also been working with Schlumberger and OneSubsea. That was quite interesting as well, to command control track and a submerged saber-tooth untethered AUV. And DriX in that frame was also acting as a communication getaway between the submerged AUV and the mother vessel. So that's
okay. So quite a wide variety of kind of operations in the oil and gas domain. I think that's about it for sort of case studies and a bit of an overview. So thanks for that, Guillaume. We have got, I know there's a number of questions brewing from the from the audience. So let's crack on with a few of those, shall we?
Of course.
So what is the maximum sea state in which DriX can effectively sail with sensors on?
Well, honest answer, I don't know the limit. So what I can tell you for sure is that we've been performing survey missions with 3 meters high waves. Okay, so because the sea state is a complicated notion as well. Huh? It's going to vary a lot given the shape of the waves, if they are breakers or not. And the period between the waves, of course. But 3 meters high waves is already something quite high.
What? So essentially, it depends on a lot of things. But with the hull form and the hydrodynamic properties, you've got an increased capacity versus a manned vessel, perhaps. So here's one about endurance. What will be the operating endurance of DriX in the highest sea state? Again, a difficult one to answer.
A very difficult one to answer. Well, let us say that the endurance of DriX the curve, let's say, the endurance curve, you'll get 24 hours of endurance if you're going full speed, 14 knots.
Okay.
And you'll get 10.5 days at 4 knots.
Okay. So just draw the line.
So, yeah.
Curve, pick your point.
So to give you yet another example, at survey speed, around 8 knots, with a C-State 3, you will have a 5 to 6 days endurance. That would be my take.
Yeah, sure. Okay. So it's a bit of a movable feast depending on environmental conditions and other factors. So here's another one about speed versus autonomy, which is something a little bit like you just answered. So what's the autonomy at 5, 10, and 14 knots? So you've given us that.
Yes, I did.
So 24 hours at 14 knots and 10 days at 4 or 5 knots, and there's a curve between the two.
Exactly.
So here's one about launch and recovery. Can DriX be launched and recovered from a moving vessel?
So to be clear, the best way to launch and recover DriX is from a moving vessel. Because with a forward speed, one gets stability for the DDS. And it's much easier to do it this way. It's what we recommend at any rate. It's much easier to do it this way than without speed at all.
Sure, yeah. So it's possible to do it stationary, but actually preferred is a slow speed, 2-3 knots, to give control for the DriX, and the DDS holds its position better that way.
Absolutely. It's also allows to operate in harsher sea conditions.
Sure. Okay. Yeah,
that
makes sense. So here's another one about launch and recovery. So what is the launch preparation time for the DriX, or from DriX DDS?
Oh, that's a good question. I'll have to answer by email here.
Okay.
It's I guess it will depend on the lifting device you are going to use. It's not a lot. I would say that 15 minutes for the people to get together. It's like a rib, if you will.
Yeah.
So a rib will take different times, whether you use a crane or a davit
and depending on the experience of the crew and the conditions and so on.
So here I'm talking about a train crew, okay, for 15 minutes.
But it's not hours. It's
no, clearly not.
Maybe 15 minutes, 20 minutes.
I'll provide an accurate answer to the asker here.
Okay. Yeah. Well, so we're going to make sort of an FAQ. So we're going to collate all these questions and answers and distribute them after the event on our website. What kind of sensors can be installed on DriX? Any sub-bottom profilers, for example?
So yes, we spoke about MBES. We can also install some sub-bottom profilers.
Yeah.
We can install, well, I'm talking about what we have installed already, okay? USBL, LBL, well, long baseline and ultra short baseline. Yeah. A lot of things, really. Magnetometers, side scan sonars, we can do all of that. Yeah. Which allows me to mention one thing we are currently sea trialing, and that is called FlipX. That's a towed body behind DriX, capable of housing a number of sensors, which needs to be close to the sea bottom.
So it could be the subject of a future webinar, perhaps. Yeah.
And why not?
Yeah. So a huge variety of sensors. We've deployed many different types of multi-beams already. Sub-bottom profilers, USBLs, etc. Here's one about obstacle avoidance. How does DriX avoid obstacles? And what dedicated sensors does it use in that?
So the obstacle avoidance system relies on the data fusion of a number of sensors on DriX topside. So DriX topside is fitted with video camera, infrared cameras, a LiDAR, which is going to be the key player in that. And we've just been contracted by a company to install a radar. on board DriX. So as you can see, a number of detection devices. Now, the way it works, we detect, and the main sensor here is the LiDAR, so 150 meters range, let's say, away from the surface track. DriX is going to implement the avoidance maneuver, the collision avoidance maneuver. It's done in the spirit of the core reg, or according to the survey in progress. Quick example, if you've got an incoming starboard track, the way you should do it would be to head for the rear of the vessel and to go behind it. But if you're running on a line mile with your DriX, you would much prefer conduct a 360 degrees turn, letting the other track pass, and resuming your line mile at the exact same spot you left it. So you see, it's a trade-off, really.
Sure. Okay. And there's an automated system to make that judgment.
Absolutely.
Okay.
So the automated system first, and in case of impossibility, DriX will report back to its supervisor.
Okay.
So
and
that's
call for help from the
call for decision taking, if needs be. That's
okay, which leads on nicely to some of these other questions. So here's one about legal framework. So in which legal framework are we considering the operation of DriX as an autonomous vessel for missions in open waters? Is that one you can give a brief and brief question to, brief answer to?
I'm not a lawyer, but of course, as you can imagine, I'm taking interest in that topic. The thing is that there is no global regulation at the moment on the planet. That doesn't mean that we cannot use DriX, or it doesn't mean that we cannot use any autonomous vessel. DriX is supervised autonomy, so there is a human in the loop. The one really calling the shots right now are more the operators of the wind farms, or the oil and gas spreads, let's say, which are going to run risk assessments and say, okay, well, yes, you can use DriX, or no, you can't. And the way we cope with the regulation right now is through the use of a mother vessel. So that's
so, which goes on well here to the next question. How does DriX differ from other USVs which do not need line of sight support from a mothership? I mean,
well, yeah, it's
the question.
The answer is in the question. Maybe not, because in fact we could pretty much use DriX beyond line of sight. It's I mean, all the technicals are there. As I said, we are putting a radar. We've got an AIS. We've got SATCOM, safety SATCOM with a heavy lag. So it's not a SATCOM dedicated to working. It's a SATCOM dedicated to sailing DriX in security, in safety. Now, it's we do have we are considering for one of our customers a high bandwidth SATCOM system with a very reduced lag, which will, in that frame, allows to operate DriX from a distance beyond line of sight. Clearly, the only thing is that today our insurance broker is asking us to keep within line of sight. But I mean, it's if one purchases a DriX, there is no technical reason why we could not use it beyond line of sight.
Sure.
It's,
so technically, there's no reason why we can't operate with Horizon. It's not. It's kind of trivial. The barriers are then just implementing a suitable communications setup.
Yeah, which we have in fact.
Regulatory.
Regulatory mainly.
If you're prepared or you're able to take the the risk on the insurance and regulatory aspect, then it's ready to go pretty much.
Absolutely.
Okay, good, thank you. We've got one here about station keeping. Are you able to keep station? What is the area you can keep within?
So DriX is going to keep station resulting to kinematics. So we are going to, if you will, to kinematically hover over a position, okay, at very slow speed, but we will keep inside the water column. So there is no DP on board DriX. Okay, it's too small, and we rather use the available the 3 kilowatts available for power supply inside to feed the sensors rather than use any propeller. I'm not saying we are not doing that. We have we are doing that on DriX, but as you pointed out in your introduction, within our shipyard we are developing other assets with DP. So we cannot do station keeping DP-like, but we can do station keeping kinematically.
Sure. Yeah. So we can sail slowly in a pattern in quite a small area.
Absolutely. Yeah.
But we're not dynamically positioning the vessel. Yeah. Back to communications. What communication systems are available or have we implemented so far? And at what distance does that then allow one to operate from the mothership? Maybe.
So the standard version of DriX comes with a Wi-Fi link, which will, again, it's a tricky question, the distance, because it depends on the environment. Worst case scenario, we saw 2 kilometers.
Okay.
And we've operated DriX around the planet, literally. Yeah. Okay. So,
but up to what's the sort of
the maximum was a bit short from 5 kilometers.
Okay.
Now,
so for short range, 2 to 5 kilometers.
That's it. And with that,
the Wi-Fi is adequate.
With that, you've got because that's important to know what sort of data we collect from that. From that, we've got the quality control, we've got the seabed data, but we don't have the water column. If that helps. Okay. Now, the other communication system we've got with the DriX are the AIS. Okay. The small SATCOM Iridium safety I told you about earlier. So that's what comes in standard. Now we've got an option for the from the maritime broadband radio from Kongsberg, which is going to give you a range extension. We assess around 10 nautical miles. Okay. A bit short of 20 kilometers, if you will. Yeah. And as I said, we are setting a high bandwidth SATCOM solution on DriX at the moment.
Okay. Yeah. So there's a range of different options depending on the operation and
absolutely
what a customer might want. So, which leads on nicely to this next question. Can DriX be operated from the shore?
Yes, absolutely. Regulation permitting. It's not a problem. I mean, the DriX command and control system, from a supervisor point of view, I think I should have mentioned that earlier, but the survey computer is inside the DriX, and the surveyor and the supervisor have a view from a remote desktop from that survey computer, just like on board the vessel. So all it takes are 2 personal computers to run the DriX and operate it. Okay, not only running, but operating it. So that very convenient command and control center can be put together on the shore without any problem.
So, just leading on from that then, and this is repeating an earlier question, can DriX operate over the horizon? Maybe just repeat the answer in case people
yes, gladly. Technically, without any problem. That's it will depend. I mean, all the solutions are available on the market on the shelf right now.
So DriX can operate over the horizon. You need the right communications framework, and let's say you need to be in the right place where regulatorily you're.
Either that or the insurance brokers or the operators or people calling the shots.
So, is DriX available for hire?
Yes, it is. So let me explain a bit here. We've partnered with a unique system which is a rental company, in order to do that. So yes, one can rent a DriX through Unix system. Now, from Xblue, one can purchase a DriX, or one can purchase, that's our business model. We can help with the surveyors by going on the field, accompanying our new customers, or accompanying some of Unix customers if needs be. Okay. I mean, the business model is very open.
Yeah. So it's evolving, but yes, it's possible to hire DriX from our partner Unique.
Yeah.
We've got one, we're going to move back to training and so on in a second, which you touched on just there. But there's one here just quickly about propulsion. Can DriX be electrically propelled?
It could. It would be a study. So if you're interested, get in touch with us.
Yeah. But today it's diesel powered. And there's no capacity right now to propel it electrically.
Let's put it this way. Today, we've got a 38 horsepower diesel engine providing through alternators, feeding the power network with 3 kilowatts of power for the endurance I mentioned earlier. So from 24 hours at top speed to 10.5 days at 4 knots. Okay. If we wanted to have the same capabilities with a battery-powered DriX, then the weight, the total displacement of DriX being 1.5 tons today, we would need to add up 4 tons of batteries.
Okay, yeah.
So
it would be a very different beast.
It would be, yeah. And this is not to say that we cannot propel it electrically. We could do it, but it wouldn't have the same capabilities. It's a trade-off.
Sure.
The diesel can be maintained by any ship mechanic in the world, basically. It's all about resilience and reliability.
Sure. Yeah, no, I understand. So here's one coming back to training and crewing. What crew is needed to operate a DriX, and what about training?
So we provide a training, which we provide a training for supervisors, for a DriX supervisor, DriX pilot, if you will. So make no mistake, we are not going to transform one person with no experience into a surveyor or a mariner. Okay, so that's not what the training is about. The training is about DriX supervision. So anyone can buy the training, which is twofold: an online part and an hands-on part, during which you are going to learn all the technicalities about DriX, how to mobilize it, how to demobilize it, how to drive it. But of course, it is highly recommended that people who attend that sort of training have already a previous background of going at sea, because it's an asset going at sea anyway. So that's and a background in their field of expertise. If the people buying DriX want to conduct survey, then a surveyor background would be highly appreciated. This is not something which is given during the training.
Sure. Okay. So just coming back to the crew, then you've got one operator for a DriX. You have one operator who's controlling and managing the DriX platform, as it were, and then you have typically you have a surveyor who's managing the survey operation and the payload, the survey sensor payload.
So that's it. And that would be the case, the format. So the operator we call the DriX supervisor, because in fact we pre-plan the mission of DriX and then DriX runs it autonomously. The supervisor is on call and can take DriX, take control of DriX manually if needs be, and if he wants to. And the guy running the DriX, the mission of the DriX, is the supervisor. That would be the format for 2 DriXs with 12-hour shifts.
Okay.
1 supervisor, 1 surveyor. If you go to 24/7, then you would need 1 supervisor and 2 surveyors.
Okay.
And that would go up to 2 DriXs.
Okay.
At the moment.
Yeah. Okay. I hope that helps. So now we've got something a little bit more in depth now about the LiDAR, and somebody's sort of making the point that 150-meter range of the LiDAR doesn't seem very much, especially with speeds over 10 knots. Is there a speed ceiling that this avoidance method will only work below? And how are you developing longer range detection capability?
Well, so for the speed ceiling, not to my knowledge. Now, this is a very interesting question because DriX turning diameter, okay, at 14 knots is 34 yards.
Meters.
Is 34 meters, if you will.
Same.
Yeah, okay. Make it 30. Anyway, it's in the 30 meters. Okay. So what that means is that 150 meters is 5 times bigger than DriX turning circle diameter, which in the frame of the call
at 10 knots.
Yeah.
Okay.
It's at 14 knots. At 14 knots.
Well,
that's
knots.
the worst case scenario. Okay. So that's already huge. Now it's all about the compatibility between unmanned assets and manned assets. I'm a former mariner myself, and it's true that I would take the same sort of thresholds to implement a maneuver if I needed to maneuver according to the call regs again. But given the turning radius of the surface ship, that would probably be a lot earlier. However, it's fully compatible with that spirit, I would say, the way DriX reacts today. There was another part to that question.
So the LiDAR 150-meter range seems insufficient. Is there any plan to increase, have a longer range LiDAR? I mean, you've got the visual and obviously the infrared.
Well, no, because it's more than sufficient, in fact. However, we have plans because it's already funded. It's been we were paid to implement a radar on DriX, which is something we are doing at the moment.
Okay, and so there's another question here which sort of leads on in the same sort of vein. No, this is about post-processing actually. But I guess the question, my further question then is that the mothership would be perhaps monitoring operations with its own radar on a kind of on the big scale.
If you are working with a mothership, like it's the case today, you have that option. Absolutely.
But the close range obstacle avoidance is more than the sensors on board are more than capable, given the maneuverability and the speed of DriX.
That's the point.
So now here's one about post-processing. So is the survey data monitored in real time on board the mothership via the data link, or is it only with post-process data?
So what you've got on board the mothership in real time is the quality control. Okay, so again, I don't know if it's possible to show the video from Quincy again that we saw earlier for the wind farms. It's quite interesting because this is the view from the surveyor during a survey.
Okay.
Hold on. Okay.
So the data that we saw, which is associated with that, is actually, it's being seen live on board the mothership during this survey.
So it's just like a surveyor on a regular survey vessel, except that is witnessing what's happening through a remote desktop because the survey computer is inside the DriX, if you will.
Okay. Yeah. So you're able to do the quality control within the survey package, let's say, but you haven't actually got the real data there.
No, if you've got part of it, and that varies depending on the communication system you're using and the distance you're from the vessel.
Sure.
Otherwise, and as I said, in any case, if you're doing seabed mapping, for instance, you will have the data from the seabed, but you will not have the data from the water column. That's a trade-off.
Sure. Maximum payload. So what's the maximum payload DriX can host? I don't know how you approach that question.
It's complicated because we are talking about buoyancy. Okay, let me try to say to phrase it like that. We need a weight of 300 kilograms in the drop in the gondola to balance the boat. So weight-wise, that would be the limit. Now, I've also mentioned earlier that the gondola can vary in size and shape. Up to today, the biggest gondola we've done was 3 meters by 1.
Okay.
And we believe we can extend it to 3 meters by 1.5 reasonably without hampering too much DriX capabilities. The real limitation would be the electronic cabinet, which is located in the forepart of DriX. If you see, look at the model here, it's just behind the X-Blue, between the X-Blue and the sail. Okay, you've got an electronic compartment here, and there's a limited amount of size here. So it's not so much a matter of weight, but a matter of size mainly. Today, in what we call a universal gondola, you will be able to integrate a EM 2040 size-like multi-beam, plus, for instance, a USBL, plus a sound velocity profiler. You see, you can do multiple things. And inside the gondola, at all time, you also have an INS to georeferentiate everything.
So I think, in summary, in terms of maximum payload, there are 3 kind of factors, I guess. One is the actual physical size of what you can deploy on the gondola. And so far, we're talking about something 3 meters by maybe up to 1.5 meter in terms of physical dimensions.
Absolutely.
A weight thing to keep in mind, maybe up a limit of 300 kilos. And then also the available space for the topside electronics for the sensor payloads, whatever that may be, within the bow section of DriX. So those are the 3.
And let's not forget the power, but again, that's one of DriX strong suit here. With 3 kilowatts of power, you've got an impulse supply.
So we've got 3 kilowatts of power, but we think that's going to be probably lower on the list of constraints. But depending on the payload, it could be a factor. So I hope that helps. So now we've got one about survey team. So do we have our own survey team which can operate DriX? Can this be rented as a complete package, DriX, survey equipment and team from X-Blue?
Yes, it could. Our department, X-Survey, can provide the full service. So to rephrase that, you cannot rent a DriX from X-Blue. You can rent a DriX from Unix System, but you can rent the full service from X-Blue, for instance. So you will have a global price for the DriX and the people. And at the end, and the data, of course, reasonably. And you can buy DriX from us, of course.
So yes, the answer is yes.
The answer is yes.
So now here's one about sensors. We picked up a little bit of this over the course of the conversation. Is DriX sensor agnostic? Clearly, yes. We can fit anything. Can you fit third-party kits? Any examples? So
yeah, absolutely.
We can fit. We're very happy to fit anybody's sensors, depending on the application and the needs of the operator.
Yeah, absolutely. It's just we'll just have to conduct a quick study, integration study, if that's something we haven't integrated yet. But clearly, the point of DriX is to be as universal as possible. So that's
yeah, sure. So it is sensor agnostic. So here's one about LBL. Can I calibrate my LBL array using DriX?
Good question.
Another nice short answer.
Good question, and I don't know.
I think the answer is yes. I mean, we've done some boxing.
For the boxing, clearly, yeah, so, absolutely.
And so any of that type of work we can support with DriX with the right sensors deployed on the gondola. So we've got another question, but I think we're maybe coming to the end here. We've got one brewing, Guillaume. So just hold your position.
I am.
What have we got? It's one operator able to operate multiple DriX. So this is coming back a little bit to the crewing question that we had earlier.
The short answer is yes. Up to 2 DriX as of today. Okay, that might evolve in increasing number in the future. But today, yes, 2 DriX is what one crew would be able to manage.
Yes, so we envisage one operator and perhaps one surveyor operating 2 DriX.
That's it.
I think that's the end of our questions, Guillaume. It's the end of the journey. So thank you very much for your contribution, your quick briefing, and thanks for answering these questions. I think you'll be happy to answer more questions if they arise in the coming hours or weeks or days.
Clearly, don't hesitate. And hopefully I'm available for traveling as soon as we can do it again to brief anybody extensively on DriX and to go maybe more into technical details.
Sure. So I think in the context of this format, hasn't been able. The objective was not to get too deep into the technicalities, but clearly we're able to connect with anyone anywhere to dig a bit deeper if that's of interest. Thanks, Guillaume. So I'm going to say goodbye. We're going to say goodbye to you here from Paris. We hope you've had an informative 50 minutes or so. We've had about 80 viewers, I think, connected over the course of the webinar. So thank you very much. If you've got any more questions, don't hesitate. We're going to be carrying on with our webinar series later today with another discussion about DriX, but then on Thursday we'll be covering a topic about our CPIC-C, our 3D multi-beam sensor, which is pretty interesting. Some of you may find that interesting, so tune into that. If not, then keep safe, and we hope to see you soon. Goodbye.